Today's question is, which of the following statement is not true? First option, HF is a stronger acid than HCl. Second option, among halide ions, iodide is the most powerful reducing agent. Third option, fluorine is the only halogen that does not show a variable oxidation state. And fourth option, HOCl is a stronger acid than HOBr. So we'll explain all these 4 points one by one. So the first, we'll explain the option number A. So whenever we try to find out the acidic strength of halogen acid, we always give importance of the electronegativity of the halogen atoms. But that's not the correct way to find out. As the electronegativity of the halogen atoms increases, it pulls the bonding electrons strongly towards itself. So that means that HX bond become very polar. But remember, bond polarity is not the key factor to determine the acidity of the HX. The key factor is the bond dissociation energy which is required to break the HX bond. Now, which is the key factor which decide the bond dissociation energy? That is the atomic size of the halogens. So here you can see all this order has been given. If you look into the electronegativity order of halogen, it is like that. Fluorine is the most electronegative, iodine is the least electronegative. The order of atomic size of halogens is like that. So iodine is the larger atomic size, fluorine is the smallest atomic size. So based on the atomic size, we can predict the bond dissociation energy of the HF. So that means HF bond dissociation energy is the highest and the bond dissociation energy of HI is the lowest. So that means this bond can break easily and in presence of water, means in aqueous medium, it will give you H plus and I minus easily. So that means this dissociation will be faster in case of HI because this bond dissociation energy is less for HI than the HF. So based on that discussion, we can say that HF cannot be a stronger acid than HCl because to break the HF bonds, it requires quite higher energy than the HCl bond. So that means option number 1 is incorrect. Now we'll discuss option number B. Among halide ions, iodide is the most powerful reducing agent. Reducing agent means it oxidizes itself and reduce the other elements. So any element get oxidized means it donates the electrons. So that means a reducing agent should be a less electronegative element than the other elements so that it easily can donate its electron so that other elements can accept those electrons and get reduced. Now, if you look into the periodic table, we can see that from top to bottom, the electronegativity of the halogens are decreasing. So that means iodine is the least electronegative element. That means iodine can easily donate its electron and which will be accepted by other element which is present in that chemical reaction. So that means iodine can act as a powerful reducing agent among other halogen elements. So that means option B is a correct statement. Now we'll discuss the last option. HOCl is stronger acid than HOBr. So to find out whether it's a correct or incorrect statement, first we'll have to write the equation. So here you can see HOCl in aqueous medium, it's give you H3O plus and OCl minus, and HOBr in aqueous medium is give you H3O plus and OBr minus. So from this structure, it is clear that the acidic proton is connected with the oxygen, not with the chlorine or bromine, whatever just now we discussed. So that means the bond dissociation energy is same for both HOCl and HOBr. So like that. So this is like a bond breaking. So both the cases we can see that OH bond is breaking. So that means here bond dissociation energy is not going to be a key factor. Then what will be the key factor here? So in this situation, the electronegativity of halogen atoms are going to be a key factor. Like we have to find out the electronegativity of chlorine and bromine. So now if you look at this structure HOCl and HOBr, you can see that chlorine is more electronegative than bromine. So that means chlorine pull the electrons of this OCl bond more strongly than the bromine is pulling the electrons of this OBr bond. So since chlorine is pulling the electrons more strongly than the bromine, so here oxygen atom is going to be a delta positive. So in HOBr also oxygen is going to be a delta positive, but in case of HOCl, the magnitude of delta positive oxygen atom will be more than the HOBr molecule. So since oxygen atom having more delta positive charge, so now oxygen will pull these bonding electrons more strongly towards itself. So now what will happen? H can leave as a H plus easily in the aqueous medium. So that means here you can see that electronegativity difference between chlorine and bromine is going to be a key factor to decide which acid will be stronger. So that means the statement which has been given that HOCl is stronger than HOBr, that is the correct option. Now we'll explain the option number C. Fluorine is the only halogen that does not show a variable oxidation state. To explain this statement, first we have to write down the electronic configuration of the fluorine. It's 1s2, 2s2, 2p5. So valence orbitals are 2s2 and 2p5. Total number of valence electrons are 7. So here if you look at the electronic configuration, you can see that 2p orbital just need one more extra electron to fulfill the octet. So that means fluorine can accept one electron in its 2p orbital. But since the principal quantum number is n equal to 2, so that means it has only s and p orbital. Fluorine does not have any d orbital where it can extend its valency. So that means fluorine cannot show variable oxidation state. So to just compare the different behavior of fluorine, here I have taken one example of chlorine. So in the chlorine you can see this is the electronic configuration and 3s2, 3p5 is the valence electrons. So here you can see that since the principal quantum number is 3, so that means chlorine having a 3d empty orbital. Now chlorine can accept one electron in the p orbital same like a fluorine. But at the same time, chlorine also can accept electrons in the empty 3d orbital. So that means it can extend the valency or it can show a variable oxidation state. So that is the reason we can see that PCl3 and PCl5 both forms. But in case of fluorine, it only forms PF3, not the PF5. So that means option C is also a correct statement. So now from this question we can say that option B, C and option D all three are correct statement, but incorrect statement is A. HF is a stronger acid than HCl, so it will be the correct answer. I hope you understand the explanation. If you have any chemistry related queries, You can send me a mail to chemistry.affinity@gmail.com, and thank you for watching.